Yeah, so we'll start. This is a discussion on uh, the daily quiz for I think week 3. Yeah, so it is. We'll discuss the daily quiz that was given to you in the third week of May month. Okay, so uh, there are around 6 problems, and we'll see. It's a combination from different topics, so that's a good thing. So we'll see. Okay, one by one we'll go. Now the first question is the integration from 0 to infinity 1 by x square dx. Okay, it's a tricky one because these kind of questions are not usually asked, but sometimes just to confuse students, they give these kind of things. The reason is, because see, if you do this in a strict, the conventional way, let's say, you can write this as x power minus 2 dx, and then the formula is n plus 1 by n, right? So that will be minus 1 by minus 1 going from 0 to infinity, right? So basically, you know, if you take minus 1 outside, it is basically 1 by x 0 infinity. So the upper limit infinity is okay because 1 by x tends to 0 there. But this lower limit, if you put, that becomes 1 by 0 form. Okay, so that blows up. So if there is a, that negative sign goes away because basically it is minus 1 into 0 minus 1 by 0. Okay, so basically it is 1 by 0. Okay, and for the sake of solution of this problem, you can take option C because it is going to infinity. But the technically sound explanation should be, I mean, if this kind of thing is asked in your exam, you just have to choose the option which is infinity. You can't do anything about that. But technically speaking, this integral or integration should, basically it does not converge to a finite value. So these kind of things, there is, we call them as, the integral diverges. Okay, so instead of infinity, you can, if this option is given, the integral diverges or does not converge to a finite value, that is the most technically correct explanation. But nonetheless, since this is a competitive exam, and if this kind of questions are asked, and they do ask, okay, it's not like this is a problem with this quiz. Even if you look at some of the previous year GATE exam questions, such things happen. Okay, so you have to be prepared. So maybe that's why this kind of question was given, because some students may get confused with the last option. None, I mean, it doesn't make any sense. If the last option is the integral diverges, then instead of C, I should have ticked option D. But none doesn't make any sense. Okay, so therefore, if it comes to that, you should tick the option number C. But it's technically divergent integral. Okay, because the lower limit is at x equal to 0. Okay, so this is about first question. Answer is C. That is also according to your solution key. Let's go to the next question. This is an interesting question actually. So, what they're asking is, the minimum number of times a fair coin. Fair coin means the probability of getting head is half, probability of getting tails is also half. Is tossed so that the probability of getting at least 2 heads is at least 0.96. Okay, so this is the trickier part. If you understand this English, you should be able to solve this question. So probability of getting at least 2 heads. So let's say there is some event, probability of that event is probability of getting at least 2 heads. Okay. Probability of getting at least 2 heads is at least 0.96. Okay, at least 0.96 means it can be more than that, but it has to be at least. So that means it has to be greater than or 0.96. Okay, so that is what this statement means. Okay, and this is a very famous this thing, at least statements. So there you have to solve by finding the probability of other cases where this is not true. So getting at least two heads in let's say n tosses. Okay, uh, at least two heads in, let's say, n tosses, because they have not put any limitation that you are tossing the coin 2 times or 3 times, and this n is need to be found. Okay, so this is the objective of this question. You need to find at least how many tosses you have to do, so that the probability of getting at least two heads is at least 0.96. Okay, complicated English, but the essence is very simple. So now, see, I can write this now. The probability of getting two heads is nothing but 1 minus probability of getting one head or probability of getting no head. Okay, so what I'm trying to tell you is probability of getting two heads at least. Okay, that is the keyword. Probability of getting at least two heads is equal to 1 minus probability of no heads or only one head, right? That is the, because if you are getting at least two, means you can get 2, 3, 4, whatever it is. And if you have the probability of getting 0 and 1 to it, the summation should be equal to 1. No? So this is what we will use to solve this question, because it is easier to find probability of getting no head in n tosses and probability of getting only one head in n tosses rather than doing this way. Okay, so that is why we are doing this kind of manipulation here. And this is the commonly used trick in this at least kind of statements. Okay. So now probability of getting two heads as per this question should be greater than 0.96. Okay. This is 0.96. And therefore, if you write this, no or one head should be greater than or equal to 0.96. Okay. And therefore, probability of getting no or one head is 1 minus 0.6, no? So that is less than or equal to 0.004. Okay. I'm just playing with the inequality here. Okay. So now this becomes simpler problem, because I can write this as probability of getting no head in n tosses plus probability of getting one head in n tosses. And that summation should be less than 0.04. Okay. Now we'll try to find each and every term like this. Okay. And you can use this binomial random variable for modeling this process, because this binomial random variable, what it says basically is it is used to model number of successes in n independent Bernoulli trials, each with probability of success A. Okay, so basically this binomial random variable, what it tells you is, let's say you did n independent trials, and out of that n independent trials, what is the probability of uh, you know number of successes? For example, it is given as x equal to k n c k a k 1 minus a power n minus k. Okay, so this is your basically PMF for binomial random variable. Okay, and we'll use that here, because here what all these terms basically represents, n represents n or total number of independent trials. Okay, so basically in our case this represents number of coin tosses. Okay, k represents number of successes, okay, in these trials. So what we'll do, we'll define success as getting head. Okay, this is our definition of success. And what is A? Probability of success. What is the probability of getting head in a fair coin toss? That is half, right? And 1 minus A, that is means probability of not getting head, that is also half. Okay. So therefore, probability of getting no head is nothing but you have to put k equal to 0. Okay, so that is p of x equal to 0. Okay, so that will be nc 0 half power 0, and 1 minus half is also half power n. Okay, so this nc 0 is 1, so basically only 1 by 2 power n remains here. Okay, and similarly now we want only one success out of n independent trials, so that is nothing but probability of getting one head. So in that case, you have to put k equal to 1. So you want only one success. All others are failures. Okay, so let's calculate that. Okay, so probability of getting one head, that means k equal to 1, is nothing but nc1 half power 1 half power n minus 1, right? And nc1 is nothing but n, because it will be n factorial by n minus 1 factorial. And this is again half power n, because powers get added, base is same. Okay, so therefore the total probability is, this is for getting no head and this is for getting only one head in n trials. It has to be less than 0.04. Okay, so therefore 1 plus n into 1 by 2 power n has to be less than 0.004. Okay, so now you can solve this by taking some logs, log function on both sides, etc., etc. But in your exam hall, this is not that feasible. So what you can do, you can take any values of n and do, because there are no options in this question. So you are supposed to take, by hit and trial. So put n equal to, let's say, 1. So in that case, this becomes 2 into half, right? So that is 1. Okay, so this is not less than or equal to 0.04. Okay, so now let's take n equal to 5. In that case, it will be 6. 1 divided by 2 to the power 5. Okay, that means if we do 5 tosses, 1 by 2 to the power 5 is nothing but 4 into 4 into 2, so that is 32. So 6 by 32, that is 3 by 16. Okay, so what is the value of 3 by 16? It is 0.1875. Okay, but that is also not less than 0.04. Okay, so let's take 10 and we'll see. So 10 will be 11 into 1 by 2 to the power 10. Okay, 2 to the power 10 is 1024. That is 11 divided by 1024, if I'm not wrong. And that value is 0.011. Yeah, and that is less than 0.00, right? 0.04. So that means your n must be between 5 to 10. Okay, now you can do hit and trial, but in the interest of time, I'll give you the answer, and the answer is n equal to 8. Okay, because if you do that, this will be 1 plus 8, so 9 into 1 by 2 power 9, right? So 2 power 9 is 512, or 2 power 8, sorry, that is 256. So 9 divided by 256. Okay, so that is 0.035. Okay, that is less than 0.04. But if you take n equal to 9, that is become 10 into 1 by 2 to the power 9. Okay, 5, basically 10 divided by 512. And that is, oh, sorry, not 9, at least, no, so 7 if you take. Yeah, no need to check 9 because that will satisfy. 7 you have to check. So this will be 8 into 2 to the power 8. Okay, so 2 to the power 8 is nothing but 8 by 128. Okay. Yeah, So this is 0.0625, okay, which is not less than 0.04. Okay, so therefore n equal to 8. So you need at least n equal to 8 coin tosses to get probability of getting at least 2 heads as at least 0.96. Okay, we check the answer. Yeah, 8. This was a very good question. Okay, so you should go through it once again so that you'll understand. Okay, now let's move on. So this is your third question. It's a linear algebra question. So what they are asking you to find is null space of this matrix A. Null space is given by Ax equal to null matrix. So where basically this the values of x which satisfy this Ax equal to null matrix, that is nothing but the null space for given matrix A. Okay. And they are saying is null space can be expressed in the form of span AB, 1, and then we have to find the value of 7A plus B. Okay, so let's find first the null space and then we'll write it in this form and see what happens. Okay, so let's define this, x as a xyz column matrix or column vector. Okay, because to get the solution for this system, you have to do row echelon transformations, right? Because RHS is a null matrix, so it is all 0. So since this is not a square matrix, determinant you can't check, so you have to do this way. So no need to worry. See, even if you want to write augmented matrix, nothing is going to change. Basically, you write augmented matrix something like this: 1, 5, 6, 2, 3, minus 1, and this is 0, 0. So our objective is always to do Gauss elimination. That means R2 minus, this will be R2 minus 2R1. Okay, so this will become, first row remains as it is, nothing changes there. So this will become 0, and this will become 3 minus 6, so minus 1. Minus 1 minus 12, so minus 13. This is still 0. Okay. And now you can then, expand this second row, because 3 minus 10. Oh, 3 minus 10. So this is 7 minus 7. Oh, yeah. And now, you can expand this system. The important stuff that you get is from this second row, because, basically you multiply this with your xyz vector, and what you get is minus 7y. So you get this system of equation basically. If you, expand this again, x plus 5y plus 6z equal to 0, minus 7y minus 13z equal to 0. Okay. From here you can get y as minus 13 by 7 into z. Okay. And you just put it back. Oh, 7, sorry. And now put this in equation 1. So what happens? Then you will have x plus 5y, right? So therefore, x plus 5 minus 13 by 7y, no, z, not y, it is z, plus 6z equal to 0. Okay. So in that, if you do this, you'll get, x in terms of z. So that is minus 65 plus 42. This will be 65 minus 42 by 7 into z. Okay, if I'm not wrong. 65 minus this thing is 23. Okay. So therefore, x is 23 by 7z. Okay. And you can see this is x by z, right? So you can write all these in terms of x only. So y is minus 13 by, in terms of z. Okay. So this is 23 by 7z. Y is 13 by 7z, and this is just z. So you can take z out, and this is nothing but 23 by 7. minus 13 by 7 and 1. Okay, so depending on the value of z, you can get different null space vectors. Okay, but this is not what they're asking. What they're asking is, here you know this null space is expressed in the form of span anyone. Okay, so if you compare this, so now you'll understand this turns out to be your a value and this turns out to be your b value. Okay, because this is your that span of a b1. Okay, because depending on z, you'll get different combos for x. Okay, and finally you're supposed to find 7a plus b. No, so that is nothing but 7 into a is 23 by 7, b is minus 13 by 7. So that is nothing but 10. And that is your answer. It should be the answer. Yeah, 10 is the right answer. Okay. So basically in this question, first you should know what is null space. That is Ax equal to null matrix solution. And then eliminate or write that null space x in the form of z and its span. Okay. And then if you get the span elements, you can find the answer. Okay. Interesting question because it tests knowledge of your null space and how to solve for null space. Very important because many students know what is a null space, but they don't know how to solve for it. Okay, so that's the interesting part. And the rest is more or less easy. Okay. And now the fourth question where you are supposed to find order and degree of this differential equation. Order is the easiest one because that is the order of the highest derivative term. So this is the third order derivative term. So order has to be 3. Okay. So option B is incorrect itself. Now talking about the degree. If this last term is not present, you can just say degree as 1. Okay. But because of this exponential dy by dx term, this, see, basically degree is nothing but the, one second, yeah, dy by dx equal to 0. See, degree is nothing but, power of that highest order derivative term when it is written in a polynomial of, in the form of polynomial for derivatives or derivative terms. It is independent of or free from the radical signs or other square root or some signs like that. But because of this exponential function, and exponential power is a derivative term, so that's a big problem because of this term, you cannot write this in, cannot express this ODE in polynomial form. Okay, and therefore degree does not exist. Okay, this is for this ODE. Okay, interesting observation because many of the students will think degree is 1, but you are supposed to be always paying attention to these kind of things. Okay, because to find the degree you are supposed to write this ODE in the form of polynomial. Okay, a polynomial of derivatives. There should be no fractional powers, no non-algebraic functions. Like basically to write degree, this non-algebraic functions like exponential, log, trigonometric functions of derivatives should not exist basically. Okay, so in this case, in this question, it is e power dy by dx. But if I write ln of dy by dx, sine of dy by dx, that is not allowed. Okay, because that does not allow this ODE to be written in a polynomial form of derivatives. Okay, and therefore the degree is not defined basically. Okay, does not exist or not defined is the better wording. Degree is not defined. Okay. One may argue that I can write this e power dy by dx as a exponential series form. 1 plus x square by 2 factorial x cube by 3 factorial. So in x you just replace dy by dx. But that does not make any sense because then it will the degree will keep on increasing and going on. So it's not allowed. Okay, so that's why the degree is not defined for this OD. That's why the option A should be the correct answer, not option C. Okay, many students will tick option C. So that was the trick here. Okay, so let's go to the next question. This is a very interesting question because they have written y as some series of x, and they're asking dy by dx. Okay, but here to solve this question they should have given you one more additional information that mod x has to be less than 1, because then this is a geometric progression, right? Because if you take ratio of third term by 2 or second by first, you get the common ratio of 1. Okay? So here the initial or the first term is a and common ratio is x. Okay, so sum of infinite GP series given by a by 1 minus r, where this r must be mod of r must be less than 1. Okay, so only then you can write. So that's why in this question they should have given you some additional information, because in that case you can write y as 1 by 1 minus x, and therefore dy by dx you can directly write it as minus 1 by 1 minus x whole square into minus 1. Okay, so basically 1 by 1 minus x whole square. Okay, and that is your option B. Okay, that is also correct option. But usually they don't give this explicitly, because if mod of x is greater than 1, then you don't have any closed form solution, and then you can't do anything. So that's why sometimes it is implicitly mentioned or implied. Okay, so very interesting question. We can use the concept of GPCEC. Okay, so that is about fifth question. And then the sixth question, basically you are supposed to use trapezoidal rule to do the integration for this cubic polynomial and 5 subintervals. So n is given as 5. This is the formula: b minus a by step size h. B is the upper limit, a is the lower limit, and h is the step size. Okay, so in this question h comes out to be 1 by 5, that is 0.2. Okay, so basically you are supposed to make a table. Here f of x is x cube here, and so let's say these are your x values and these are your f of x values. So they are telling you to take steps of 0.2, then only you'll get 5 subintervals, right? So in this kind of questions, you are always supposed to create these kind of tables, so that because you need function values at each in order to get the solution. Okay, so if you have x equal to 0, this is 0, x equal to 1 is 1, and now you are supposed to get the cubes of this. So 0.2 is 0.008, this will be 64. Okay, what about 6? It is 216 now, so 0.216, and 8 is 64 into 8, so that will be 512. Okay, so this much information you have, and by trapezoidal rule you can write this integration 0 to 1 x cube dx as h by 2. We can call this as y also, because that's easy to write. That will be nothing but y0 plus y1 into 2 will be there. Okay. Oh no, y0 and y1 they don't have anything. 2 will be multiplied by rest of the y values. Okay, so so y0, I mean, See, by y0 I mean this is your y0, this will be your y1, y2, y3, y4 and y5. Okay, so here this will be y5, not y1. Okay, it's just the matter of notation, nothing different here. So first and last function value plus 2 into all other function values. Okay, so y1, y2, y3, y4, bracket complete. So this will be your final answer. Now you just have to plug in the values. Okay, so that will be h is 0.2 by 2 into first and last value, that is 0 plus 1 1 plus 2 into the rest of the values. So that will be 0.08 or 008 plus 0.64, then 0.216 and 0.512. Okay, so this summation will come out to be 0.8. Okay, because 16 plus 12 is 28, plus 8 is 36, plus 64 is 100. Okay, so that is 0.7 plus 0.1, 0.8. Okay, so this is 0.1, 1 into 2 into 0.8. Okay, so that is 1.6, 2.6 and 0.26. Okay, so this is your value. See, this will be not exact, okay, because this is as per the trapezoidal rule. Okay, the exact value will be nothing but x power 4 by 4 is 1 by 4.25. Okay, so sometimes in this question they have not asked, but they will ask error or absolute error, relative error, all those things we have discussed in the regular classes. But as far as this question is concerned, the answer should be 0.26. So option C. Okay, yeah, and that is also as per your answer. And I think this is the last question in this quiz. Yeah. Okay. So with that we'll stop, and maybe we'll meet next time in some other video. Okay.